Well, we have a new problem, and it seems a bit interesting. The problem is about maximum Coulomb force on an uncharged dust particle. Uncharged dust particle. That means some kind of angle of polarization, some kind of polarization is in the center. In fact, let me read you the problem. At what distance from the center of a uniformly charged ring of radius r? Okay, this is a uniformly charged ring having radius equal to r. On its axis of symmetry, should an uncharged dust particle be placed so that the Coulomb force acting on it is maximum? The electric field produced by a uniformly charged ring at its axial point is a variable. In fact, I can, if I take this axis as x-axis and origin at the center of the ring, I could remember the formula that electric field at a distance x from the center of the ring can be simply written as 1 upon 4 pi epsilon naught, that's in vacuum, by qx and x square plus r square 3 by 2. So this is a function of x. Yeah, this is variable. So if we place uncharged dust particle, it is going to be polarized because when we place this uncharged dust particle, it will have, since all things are made of atoms, it will have a center of positive charge and a center of negative charge. And center of positive charge will be pushed in the direction of external applied electric field, and negative charge in the direction opposite to it. And a small shift between centers of positive and negative charges can make it polarized, so that we can visualize it like a like an electric dipole along the axis. The dipole moment should be along the axis with center of negative charges here and center of positive charges here, slightly displaced from each other. And this is an electric dipole and placed in an non-uniform electric field, so it is going to experience some kind of force. And considering little variation in the external electric field, we consider the force on this dipole will be something like minus px dex upon dx. And both are in fact variable here, this one and this one. So, and you can perhaps remember this px is directly proportional to ex, not equal to, but ex is directly proportional to px. You must have studied the formula. And the electric field due to an electric dipole, and you can calculate ex in terms of px, and they are directly proportional for a given distance x. And so that we can write here that fx is directly proportional to ex multiplied by dex by dx. And now we can use the expression for the electric field on the ring axis, and that is equal to Ex equal to Qx divided by 4 pi epsilon naught x square plus r square. R is the radius of the ring raised to power 3 by 2. Of course, Q is the charge on the ring, we don't know its value. Epsilon naught is electric constant, and x coordinate is measured from the center of the ring. We will going to find after calculations that fx, you can find the derivatives, and you will see that this fx is directly proportional to x. R square minus 2x square divided by x square plus r square raised to 4. And perhaps you need to differentiate fx again with respect to x and equate the derivative to 0, and you will be able to find two values of x at which the magnitude of the force reaches local maxima. And the two values I got were 0.29 r, and the second value was 1.10 r. And comparing the value of the force at these points, we found that at point x1, that is at a distance 0.29 r from the center of the ring, the force is greatest. So this will be the answer. And one thing that is interesting to note, that this x is less than r by root 2, and that means the dust particle is repelled by the ring, and for the value x less than r by root 2, the dust particle is repelled by the ring, and for x greater than r by root 2, it is being attracted. So it was interesting. Thank you very much for watching.